Hello. Okay, so the microphone is on, great. Okay, so I just set up Kubernetes cluster provisioning straight from catalog inside of ServiceNow. This is in addition to a lot of the catalog offerings we had already had in place. CentOS 7, RHEL 7, RHEL 8, 2016, Server 2019, Server 2019 with SQL 2017. This also has the capability of installing IIS as well as other things. So we're looking to do full service provisioning straight from catalog items in ServiceNow onto, in this case, VxRail, Dell EMC VxRail with vSphere. All right, so let's get started. First, we'll take a look at the environment to verify we don't have any of these machines we're about to create. Kubernetes clusters. We're using PKS underlying to manage the Kubernetes clusters. We've got that installed on top of the VxRail with the NSX-T handling container networking as well as management networking and just pure network virtualization for some of the instances we'll be provisioning. So as you can see, no PKS clusters, no Kubernetes clusters as of right now. We're going to name the VM Flurkin, and which is the name I've chosen to provision. So, all right, clear's not working. All right, well, let's get started. First and foremost, we're going to name our Kubernetes cluster. We're going to call this BMK801. I'll be the owner today. Well, this is a small cluster, so this is indicative of one master node, 3 worker nodes in our Kubernetes cluster. So this cluster name will be appended to the domain name of the VxRail by default. At the moment, there's no way to change that, but you could easily extend that to a multiple domain or custom DNS suffixes. All right, we're just going to add this guy to the cart. So this will be our small cluster. Add to the cart. Let's get a number 2 cluster here. We'll go with a medium size. So this is indicative of 3 masters, 3 worker nodes. We'll also add to this guy to the cart. So it's 2 Kubernetes clusters we're ordering here on this order. All right, we'll throw in Flurkin, SQL, 01. All right, we're going to go with a large one. So the SQL server, this is 4 vCPU, 12 gig of RAM. We'll add that one to the cart. Alright, let's throw in one of these CentOS 7 boxes. We'll call this Larkin Cent 1. I'll be the owner again. We'll do this in a medium 4 and 8, 4 and 8. So add these guys to the cart, proceed to checkout. Okay, it's a lot of money worth of instances, so this has an approval process by Eric Schroeder. This is built into ServiceNow. That's why I like fronting this stuff with, ticketing systems. For the most part, they've got a built-in workflow that you can take advantage of that's, already got users. So we're just going to flip over to Eric here and approve this workflow. I've got some favorites here. This one's requested. We'll go ahead and accept all of these. All right. You can see SQL Server is a lot of money. Right now, Kubernetes clusters are cheap, but they're going up. So, all right, we just approved all of these. We're going to flip back here, take a look. This is using mainly Ansible for orchestration on the back end. You'll see machine creation kicking off. Take a look at one of these. These are passed with tags. You see this is a CentOS box. It's using Terraform underneath the cover. So Ansible is essentially kicking off a tower job. The tower job's calling Terraform plans, and it's provisioning the infrastructure in vSphere. You can see Here's our Flurkin sent box coming up. The SQL box is provisioning here. We didn't. Go here and look at the clusters. We see here we've got our medium and small clusters with the names provisioning here. So Kubernetes clusters, they take a little bit of time. You'll see the stem cells lighting up here on vSphere as PKS starts to provision out the infrastructure here. So this takes a bit of time. We'll watch that, of course. Take a look at our Ansible tower jobs. You can see our two machines are creating. This is the sent one again. I wanted to see if I could get a look at the SQL one. So this one is going to install SQL and join the domain. I'm using a tag method to light up tower jobs based on the instances in this array here, right? Which is essentially just a list of items, in this case SQL 2017 and domain. So a few jobs will kick off, right? Join domain, install SQL. We'll see those go as time moves on. You see the stem cell operations taking place here. vSAN, of course, is doing a bunch of things. vSAN is backing the storage for the VxRail cluster. Okay, all of this takes a little bit of time, so we'll break while these things stand up. I think our sent box is already ready to go. So let's see if we can SSH to it. Sure enough, you see we're IP'd up. Got our domains. DNS is all set up. These machines are being set right on top of NSX-T. You can see here there's some logical segments that are essentially backing these virtual machines. So what we're doing is dropping them on NSX-T logical segments and allowing NSX-T to virtualize the network. These are overlay networks, as you can see, labeled as such. We'll go back here and our impersonation. Take a look at the request and see if we can get some data about their process. So you see our SQL box, our sent box, up to 30 minutes for a Kubernetes cluster to provision. You can see there's our two Kubernetes clusters. I named this process OpF. I'm not sure why. Operational efficiency. You'll see there's some inventory updates. These tower jobs, they just run and kick off the machine. You see this one is, it's done with the Terraform. It's going to take a pause and start to act on some of the software components. All right. Okay. We'll return whenever these machines. This one looks to be finishing up a little bit. We'll pause for a moment and return to check out the machines after a brief break. Okay, while we're waiting for some of this to provision, I wanted to take a look at the SQL job. So there's something that I really like about leveraging Ansible for SQL and feature installs and essentially anything for desired state configuration. I find desired state configuration is, hard to write in PowerShell. So I like that Ansible has put it into a format that is YAML based, so it's a lot easier for me to read and write. These things look like, let's see. They write out just like this in YAML. This particular playbook is leveraging DSC down here. it's going to essentially, if we walk through it, it's going to install some PowerShell modules required for DSC. It's going to pull down media from a repository URL. We unzip it, and then we do the install using DSC commands, leveraging the unzip install. So I think that's pretty sweet. It works fairly well. There's a lot of customization you can do here, and as far as providing the DSC, you could have DBAs providing instructions. You see we've got drive layout definitions here that are very aligning with tempdb and database and log layout stuff. So look back at our SQL box here. SQL job's still installing, so we're waiting. The sent box, we verified it's up. It's now incrementing uptime, doing its job. SQL box here. All right, and a request. So we'll come back to check out our Kubernetes clusters. You see, here's our Kubernetes clusters. We'll take a look at details on these guys in the provisioning process. We can expect that these go well. They complete provisioning, and we update DNS so that application owners can get and connect to the Kubernetes cluster. So we'll go through a deployment as well. Okay, so while we're doing some more waiting, we'll take a look at the ServiceNow integration with Tower here. So this is fairly simple integration. We have the workflow components inside of ServiceNow, essentially, which are pretty robust. They've got all kinds of workflow automation stuff. I like to kick off workflows from here, but I don't spend a lot of time learning the workflows. I think it's super powerful, but I'm not a ServiceNow expert, and I spend more time with Ansible. So what I've done is developed a technique to essentially kick off Ansible workflows straight from a ServiceNow workflow. We'll take a look at them. I get them to them in a strange way. Here, let's see. We'll grab this guy. All right, so these catalog items have a process engine for the workflow. This is the one that I've defined here for this workflow, which is ordering the SQL Server. You can see this is getting to the workflow editor. So if you see here, essentially, this is a ServiceNow workflow that begins, kicks off a custom workflow that I've designed, an activity, and then hands it off to the end process once it's complete. So these custom workflows are essentially just an activity calling an execution command to the mid server, calling an Ansible playbook. So if you look at this here, this is calling Ansible playbook. It's reaching out to a playbook file that calls a tower launch that launches the main job to orchestrate the VM creation. This passes some extra variables here. We're getting, what template. This is essentially essentially translating to the Terraform template, machine name, the owner, the request ID from Ansible, or from ServiceNow, I'm sorry, and then the VM size, and then that apps list that I was talking about earlier. So this data, with this data passed through as extra variables to this playbook, we can then pass that data on to the Ansible jobs that it's kicking off, whether tasks or additional playbooks or tower jobs or what have you. It can start to supply that data provided in the request form, right, which is simply these inputs here, straight to the playbook. And then once it's done, ServiceNow kind of cleans its hands of the job, and Ansible and the tower jobs will then go update the ServiceNow tickets with the information that, as the request starts to move along here. So So it looks like not only was our SQL job completed, but our ticket was updated as well. So you'll see we've got a successful in the install and the create virtual machine. We'll come over here, take a look at our SQL server. All right. Let's see, it supposedly joined the domain, so let's check that out. This Terraform instance is not utilizing virtual machine templates. These are actually parameters provided inside of the Terraform TF file, right? There, let's look and verify our SQL instance is installed. Looks like you got SQL here. Got the services. Here they are. They're running. Joined to the domain. It's got our 4 vCPUs, 12 gig of RAM. Still running a little hot from all the activity. We got our Linux box. See what our Kubernetes clusters are doing. They're still building out. These guys take a little while. There's a lot going on here, so we exercise patience with Kubernetes clusters. Let's see if we can get this this job, this request number. Okay, so here we go. Still waiting for Kubernetes clusters. Oh, it looks like one has been completed. Our small cluster has been completed. It's got a little bit of formatting, but you get the gist here, right? We've got an IP. We've got our Kubernetes cluster. Let's take a look at it here. It says 01. So we're going to take a look. Here's our IP. Here's our Kubernetes cluster. It's the small one. Let's ping it to make sure the API is available. There we go. So we got a registration in DNS based on the automation workflow. It actually waits for the completion, grabs this IP, and registers it in DNS. Let's see what our second cluster is doing. Still coming up. In the meantime, let's deploy something to the cluster, yeah? Okay, so let's see, PKS clusters. This one succeeded, as you see. We're going to get out of here. I have a little repo I've been using to do some namespace and essentially deploy the Yelp app. So we'll operate in here. Let's make sure we're logged in. And PKS login. We'll do the skip SSL validation. Alright, PKS clusters. Oh, they're all done. Well, and then let's do the medium one. So that's PKS cluster. Let's get the detail, make sure it looks good. Details. Alright, this guy looks like he's up. He's got his node IP blocks. All the definitions here for NSX-T are defined. Make sure we can ping the API. DNS resolution is required for connecting with here. So we're going to get credentials for the cluster here. That way we can just switch right into the context of the cluster. All right. So we'll look at these files real quick. we'll apply this one first. Essentially, this is going to establish a namespace for us called prod Yelp, where we'll deploy the Yelp application. So namespace apply namespace. Right. Now we will see what we've got here. That's our network profile. Okay, now we'll apply this one right into the namespace. So kube.all apply. Let's make sure we know the namespace. Yeah, kube.all apply. CNA web name. And we're going to go look at our namespace. Just prod Yelp. All right, so now we deployed into our new namespace. We can use kubectl to take a look at the service. Helps if I look in the namespace. We'll get the service. Here's our external IP. We'll kubectl get pods namespace prod Yelp. All right, so if we look at the definition for our app here, you can see we've got 9 replicas of each. So I did that just to scale it out. We can, if you look here, we've got these replicas in this replica set, which is essentially holding the pods for the deployment, database, UI, app server. So if we look here, get service, prod Yelp, we'll see we've got this external IP. So the first thing we can do is just go look at our app, see that it's deployed. If you see here's our Yelp app. So obviously working. You can see here's our app server that we're connected to. All right, then we can take this guy down to, let's say, 3 pods per, just to scale down. I think that'll do everything. So now we'll reapply our manifest here to the prod Yelp namespace. All right, so now we can look inside, get service, get pods, prod Yelp, and you'll see it is bringing our pod count down to the one defined based on our declared replica count. So that's it. Essentially, we've got a CentOS box, SQL Server 2017 on Windows Server 2019, 2 Kubernetes clusters, all deployed from ServiceNow Service Catalog. We'll go back and look at this request, make sure everything completed. You can see here are 2 clusters, here are 2 boxes. This stage of the ticket is closed and complete. All right, well, that's all I have to show you today. I hope you found this interesting. We'll be hosting all of the code on the GitHub repos once I get it in order. All right, enjoy. Have a good day.